Good day everybody and welcome back to the channel. So in this video what I'm going to do is try and work out, as I said, what to do about the power supply. For the moment I've just got one of the main rails hooked up to the bridge and one of these big 10,000 mic 100 volt caps, and then that's going into the load bank. And the reason I got two clip leads doubled up is because those clip leads are really thin. All these other clip leads will handle about 10-20 amps. These only handle about 5. I made them myself. They're better than the original wire that was on them, but it's still not enough, so I just doubled it up. I mean, honestly, this is the 240 volt side. It's, what am I saying? Yeah, true that. That is the 240 volt side. There is no way this is going to cause a problem. So there we go, just a single one will do. Anyways, I'm going to power this on through the dim bulb first, just in case I've buggered something up. It happens. Looks like I have buggered something up because the bulb is on and it's not the primary side, the secondary side that I've buggered up. So I guess this must go around the other way. Yeah. Okay, yeah, and I see 50 volts over there, good. So I know everything's hooked up. Alright, so we've got 59 volts. Now, that's already making me happy because, I mean, let's just see quickly. Actually, I'll turn the dim bulb off. Okay, we got 60.64. If I go over to here, I've got 66 volts. I'd rather have all of the winding used. Personal preference. Okay, so that's cool because that's already... Oh, let me just put a load on. Alright. 60.62 volts. Alright. Well, I mean, at least that solves my capacitor bank problem. I've got 63 volt caps. You know, with no load, there's only 60 volts here. With the amp powered up biased and all that, it's gonna be... Let me just put 1 amp load on it. Alright, it's already at 55.75 volts. Just out of curiosity, that's 55 to 60, so 5 volts. If I have this running off of this tap, that's 66, and I'll put 1 amp on, we go to 60. So 6 volts loss like that, and 65, 55. 10 volts loss like that. So, yeah, I was worried about that. The extra resistance is just going to create a lot more sag. What to do? Because I certainly can't run it the other way unless I use these caps and just make up another cap bank. I always use the other cap banks that I've just made for another amplifier that runs at a lower rail voltage. Obviously, it's not like... It's just annoying because I just made them, you know what I mean? Well, this leaves some thinking to do. What I might do, I'm going to put the 1 amp load on, and I'm going to just quickly increase it and see how much it drops from where it's dropped to with the 1 amp. So 2 amps is another 3 volts, 3 amps is another 3 volts. So for every amp, I'm losing 3 volts. This shits me. It's got this overload function. If you overloaded it, locks you out, and this button that you press. Oh, I've turned the current up too high. Okay, cool. What is ringing? I don't know about that. I think maybe I should put the scope on it. It's only a 2 amp load. I've got a 10,000 watt cap on it. It's only 100 watts. I can hear, I don't know if you guys can hear that, but I'm not sure if that's the conduction angle of the diodes firing away and the pulses coming back into here and oscillating. Maybe I need better snubbers. I'm just going to go grab a couple of 104 caps, and I'm just going to hold them over some strategic locations. Okay, so that resonates worse, you can hear it. I had a feeling it was that. Let's see what's going on over here. Okay. It's not the diode bridge. Those snubbers are working. This is actually causing a problem, I think. I'm pretty sure. Yeah. Yeah, no, that's definitely making it resonate in a bad way. I'm just going to leave that lifted. I'm just going to go grab a 10 ohm resistor and a 100 ohm resistor. Where are the 100 ohm, 10 ohm resistors? There they are. Let's add some damping factor to this. So 10 ohms makes it ring more. Yeah, so any capacitance over that is actually adversely affecting it. I can literally hear the ringing. It's not nice. You know what, I'm just going to grab another one of these bridges out the drawer, because I've got more. I don't have snubbers on them. Let's see what it sounds like, just, you know, on its own. Is that quieter? Okay, that still makes it worse. Hold on a minute. I don't know, I think that's actually worse with the snubbers. I have to get the scope on. I'm going to have a look at this. There's always more work to do when you're trying to build something that's, you know, really high quality. You can't just rush it, you know, you've got to look into every little thing if you want the quality. Alright, scope started up. I'm not referenced to ground on anything here, so don't be alarmed with what I am doing. Just in case I still checked. Okay. Alright. I didn't think I was going to say anything on the DC side, but I'm a curious person, and I just wanted to see if there was any spikes making it through, because obviously that's going to end up inside the amplifier, which is quite important to me. I will show you guys the screen as soon as I've got this set up and I'm not being a curious one. Come on. Alright, times 10 apparently. Wow, we've got some stuff going on here. Where's my measure? Let me just set my probe to 10x so that you guys, when you look at the screen, are not confused. The math will be set accordingly. Alright. That's interesting. So, without the capacitor, with the capacitor, you can clearly see that spike gets worse. Smaller without it, bigger with it. Okay, so that's the first interesting thing to note. Let's have a look. How am I going to do this? Let me just have a quick look at that waveform so I can get a visual memory of it. Actually, you know what I'll do? I'll hit stop so that wave's stuck on the screen, and we'll swap this over quickly and we'll both look at it at the same time as I go to hit the run button. That way we can see the difference in the wave live. Yeah, that's definitely quieter without it. Let's gingerly hook this up again. Alright. We ready? That's what we had before. That's what we have now. I didn't actually see a difference. I'm going to have to stop the video and go back myself quickly. Let me just review this footage. Alright, well that's interesting. There's no difference between the rectifier with the snubber and the rectifier without the snubber in terms of the AC waveform or the DC waveform. So I'm going to use the rectifiers with the snubbers. That's what I'm going to do. But I'm going to remove these because I don't know if it's in conjunction with the rectifiers or if it's... I'm not going to claim that I know exactly what's going on here, but it is forming some sort of tank circuit with something, and instead of shunting noise, it's actually creating more of it. So, there you go. Even when I put this on there, I hear it get louder by a very small amount, but that is just the load. I can tell a difference because the load, it's like 100 hertz, and that other sounds, I don't know if you guys could hear it, it's a higher frequency sound. You can hear the edges, the high frequency content of what's happening. So yeah, anyways, back to the main topic. So that's cool, because now I know something else that I would have never known if I didn't do this. This is the beauty of taking your time and going through everything. You find out so much more than what you would have found out if you didn't, you know? And I'm sure not everyone's watching all these videos, and that's fine. They'll miss out. But I'm very thorough. Alright, I need a way of loading this down more. Let me just do some maths quickly on the computer, because I've got my big resistors there. I might be able to rig up a load out of that to simulate 7, 8, 9, 10 amps, something around that ballpark. I just want to see what the voltage drops down to and compare it with the two windings. But at the moment it's not looking good, because it actually looks like I'm going to have to run it like that or run it boosted like that, which is what I was originally going to do. I got the best performance, the least sag out of the transformer by using all of the available winding and running a high input voltage into it. But again, the problem is I end up at 63 volts then, exactly. And caps the 63 volts, so the joys of designing stuff. Let me do some quick math and I'll be back. Yeah, that wasn't hard. 63 volts into 8 ohms will be 7.875 amps, which is seriously so close to what we need. So all I'm going to do is take this, reconfigure. Sorry, I can't get this on camera. Well, I will in a sec. I'll just put this on my chair. Let me just... Let's let it come out. There. Alright, I've got an 8 ohm load here. What? Oh, I had this hooked up wrong. That's funny. Actually, no, I'm not sure what I've done. Oh no, they're all separate. Sorry, I know I'm just talking to myself over here. I didn't want to make a big bang. Alright, so I've got my big load over here. Let me just test this out. Now, there we go. That's 8 amps. So let me bring this over here. So it's where you guys can look at it. And I'll hook this up to the secondary. Please don't ever do the shit you see me doing at home. Just don't. Alright, so this is basically the load that's going to be on it when it's driving a 250 watt load into 4 ohms. That's why I'm simulating this. We're left with 47 volts. So that's what? That's like a 15 volt drop. 60, 40, 13 volt drop. Always gets me. Let's see what we get now. That's basically the same drop. Hold on. 50. Say 51 will be fair. 51 to 66. 52, 53, 54, 55, 56. That's 15. Wait, am I tripping balls? Oh, that's 15 volts difference. So with more winding, yeah, that drops less. Okay. Hey, that's my problem solved. So I can hook it up like this. That's, oh, you know what problem we've got now? The fan circuit. Ah, the fan circuit. That's right. Oh, this is annoying. This is annoying. I think I'm just going to buy those transformers that I showed you guys in the last video. And, yeah. I think that's the only thing that's going to work out for me. Just get custom transformers to do the job properly. Let me think. There's not really anything else I can do, is there? Let's pause the video for a sec. Alright, I know what I'm going to do. When I run it off the whole winding with the boost transformer, I got 63 volts. But that's unloaded, so when it's running the amp, it'll probably be about 60, like that again. Which means I'll be alright. And then, you know, I'll just keep the same cat bank that I've made, use that, and then I'll just order the new transformers. But at least I'll be able to run the fans and the amp at the same time. And because I'll have a fairly high rail voltage, 60 volts roughly, I'll be able to work out also how the dissipation is going to be, you know, at the higher voltage. So, alright, I'm going to leave that there. I'm happy. I'm happy with the snubber. I'm happy with the caps off the transformer. I'm happy with the voltages. I'm happy with... I've got my answers. I have all my answers now, so there you go. Sorry if it was a short video. I did say that the only other video that I was going to do before building this thing was literally looking into the power supply. That's all I had to do. I've worked out what transformers I'm going to buy. And I've worked out now how I'm going to hook this up and what voltage I'm going to get and all that sort of stuff, cat bank. So I'm happy. Alright, sorry if that was a short video, but it had to be done because tomorrow I'm going to be pairing the driver board with the power supply and the output stage and doing measurements. Alright, well, thanks everyone for watching. I'll see you all soon.